So this is target round number 6. It's about the Knights of the Round Table. So in how many ways can 6 knights be seated around a round table if 2 of the knights refuse to sit next to each other? And this is the important part. We're going to have to count rotations as the same arrangement. So what that means is, imagine we have our table here and we have the 6 chairs, and these 6 people seated, I'm calling them A, B, C, D, E, F. These 6 people can sit in these 6 ways, but we're going to count them as the same thing, because notice that, see, if we just take this A and then we rotate A until it's in this position, now everyone else is still seated in the same place relative to A. So all of these arrangements here are the same, because if you look at them, just rotated a little bit, then it's the same thing. So that's what it means. In order to get around this, one thing that I like to do to save time and to make the problem a bit easier is to just assign some spot. So let's just suppose that I'm going to put A just on the top here. And I'm going to say, okay, I'm not going to let A move anywhere else, because if A moves somewhere else, then I'm going to get an arrangement that's going to match something that I've already counted. So if we keep A in the same place the whole time, then we don't have to worry about counting the same rotations anymore. So now that we have person A on the top, we now have 5 seats left. And let's suppose that this knight, person B, refuses to sit next to A. So now B has to choose one of these 3 seats to sit in, so that B is not sitting next to A. So B, I'm going to write this on the side here. B has 3 choices on where to sit. So let's say that, just for the example, so we can keep going with the problem, I'm going to put B in this seat. But you have to think to yourself that B could have gone in any one of these 3 seats. The important thing is that in any case, person C, who we're going to seat next, is going to have 4 seats remaining to choose from. So C, because C doesn't care where he goes, right? So C is going to have 4 choices remaining. So let's suppose that I put C in just any one of these seats. It doesn't matter which one. We'll see that now person D will have 3 choices left. And once D is seated, then E will have 2 choices, and F will now have 1 choice, the last seat. That should not have an S there. 1 choice. All right, so now we have this list of all of the knights and the number of choices that they have. So what you do with this is you multiply them together. And the reason that we multiply is because when you have choices done one after the other, you will multiply them. So there's a distinction between when you should add these numbers together and when you should multiply. Because these people are choosing one after the other, and we're taking the total combination of all of these choices, that's why you multiply. So we have 72, and that should be the number of ways that we can seat these 6 knights. And there you have it. So the answer is 72.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.